I know we're supposed to do only the odds, so I'm going to skip around. If I think it's too simple, then I'll do some that you did today in class, right? I'll look at this. So it was the odd numbers, right? So theoretically, you're supposed to have finished the odd numbers in the back, but because if you look at 1 through 13, they're quite simple. But nevertheless, I'll skip around and do a few here and there. If I find my pen, there we go. All right, let's do the first one. I guess absolute value of 6 times n is less or equal to 18. So let's think about that when that is true. In order for this to be true, right? So forget that 6 times n for a second. In order for that, take the absolute value of a number and it has to be less or equal to 18. So this will be true. Well, if I take the absolute value of 18, that's going to work. So that works. 17, 16, 15, 14, 13, all the way to negative 18 also makes it true. So if I take the absolute value of any number between negative 18 and 18, it makes that inequality true. So what I'm looking for here is now I got to multiply 6 times n, right? And somehow it has to give me a value between negative 18 and 18. So let's look for the values of n, which will make that inequality true. So let me find some numbers here. So this is going to be an n problem, right? I'm going to think about it. So 6n, this, right, has to be between 18 and greater than negative 18. This is easy to solve. We divide by 6, divide by 6, divide by 6. So we get negative 3 less or equal to n, less or equals to 3. So the values of n, right, that you can pick to plug in here and multiply by 6, as long as it's a number between negative 3 and 3 inclusive, makes this inequality true. So let's pick, I don't know, pick 3. 6 times 3 works. Pick negative 3. 6 times negative 3 is negative 18. That also works. Pick negative 2, negative 1, 0, 1, 2, 3. But pick anything outside here, left of negative 3 or right of 3. Pick 5. 6 times 5 is 30. Take the absolute value of that. It's not going to work. So we're restricted to this area. So, and we can also write it like this. Oops, sorry. It should be brackets, not parentheses, brackets. Negative 3 all the way to 3. There. So this, and this. And that's the first one. I'm going to skip 3 because it's pretty the same. Let's do 5. So 5, again, remember we talked about we want to get rid of 5. So we're going to do minus 5, minus 5. Let me get a simple inequality. Absolute value of x is greater or equal to 6. When is that true? Well, for this one, we don't even have to, there's nothing to solve, so we can just think about it. Right, so think about a blank one here for a second. Well, actually, I don't even need to do that because it's just x. What is the absolute value of something greater than 6? Well, it's greater or equal to 6. It's greater or equal to 6 when x is 6, x is 6.1, 6.2, 7, 8, 9, 10, anything that way also works. But if 5 won't work, 5.99 won't work, 4, 3, 2, 1, 0, negative 1, negative 2, 3, 4, negative 5, negative 6 works. Nothing here in between these two numbers works. So the negative 6 works, and so will every number to the left of it. So x, in this case, has to be, for this to work, has to be a number less than negative 6 or equal to negative 6, or x is going to be a number greater or equal to 6. Yeah, that's it. Right. So I guess, like I said before, the first page, there's not much to do. Let me do 9. 9's a little bit more. So 9 has absolute value of x minus 2. Minus 5 is less than negative 2. So we did plus 5 on both sides. We're going to get absolute value of x minus 2 less than positive 3. All right, let me take this to the side and think about when is that true? When can I take the absolute value of something and be less than 3? Well, let me draw a number line here. If I take the absolute value of 3, will it work? No. What about 299? Yes. 2, 1, 0, negative 1, negative 2, negative 3. It doesn't work. But anything between negative 3 and 3, not inclusive, does work. So this, right, x minus 2, whatever you pick for x, subtract 2, has to equal a number between -3 and 3. So, like we said, to make our lives easier, we can think of this as a my pen's not moving. Oh, here we go. As an AND problem, right? So this guy here, now highlight. Oh, come on, pen. Here we go. Now highlight. This, again, whatever number you pick, subtract 2, has to equal something between -3 and 3. So the inequality that we set up is this. X minus 2 has to be less than 3 and greater than -3. We're going to do plus 2, plus 2, plus 2 on this side. That goes away. We're left with x isolated. Here we get 5, and here we get -1. So if I ask you to pick a number for x to then subtract 2, you can pick any number that goes from -1 all the way to 5, not inclusive. Let's try one. Let's try 0. 0 minus 2 is -2, and -2 is less than 3. The absolute value of -2 is 3. Let me pick 4. 4 minus 2 is 2. Subtract 3. Does that work? Yes. Let me pick 5. 5 minus 2 is 3, and 3 is definitely not less than 3, so that doesn't work, right? So that's kind of confirms that 5 is our, it's how far you can go on the positive side. -1, well, -1 minus 2 is -3. Take the absolute value of that, you get 3, and that's definitely not 3. So we're restricted, so the x values can be any value between -1 and 5. So between -1 and 5. What was that? 9. Let's go to 13. Okay. Let's go to 13. It's a little bit more challenging. 13. Well, there's nothing to simplify, so we can go straight to this. Start thinking about this. When is this true? Well, it's true under these conditions. 34, no, so it's not going to be shaded. 33 works, 33.99 works, and it's going to work all the way to, but not including -34. So it's another and problem. Right, so whatever value that you're going to multiply by 10, then subtract 4 has to equal a number between -34 and 34, not inclusive, to make that inequality true. So we know that 10p minus 4, right, this value here, this guy here, has to be between 34 and greater than -34. And that's how we solve inequality. So this part, I think, is important because it helps you set up the inequality, right? Plus 4, plus 4, plus 4. You get 10p, 38. Here we get -30. We're going to divide by 10, divide by 10, divide by 10. And leave it as a decimal. So p, 3.8, and -3. So to represent the values of p that we can use, it's going to be between 3.8 and -3, not inclusive. If you pick any of these numbers from -3 all the way to 3.8 and you plug it in here for p, it makes this inequality true right here. Sorry. Let me pick 0. 10 times 0 is 0. -4. Is that the absolute value of -4 less than 34? It is. Let me pick, let me pick 4 here. 10 times 4 is 40. 40 minus 4 is 36. Absolute value of 36 is not less than 34. So you already see that we're proven that numbers to the right of 3.8 doesn't work. And you can do the same on the left side. So this won't be -3 all the way to 3.8. So this represents, this guy here represents the values for p. Okay, that was an AND problem. Let me see if there's an OR problem. Right, the following one, 15 is an OR problem. So 15, nothing to do. We can already start thinking, hey, when is this true? When is the absolute value of something greater than 11? Well, it's true if you take the absolute value of something that's greater than 11, like 11.1, 12, 13, 14. Does 10 work? 9, 8, 7, no. All the way to -11. None of these numbers will work. But if you pick a number to the left of -11 and you take the absolute value, yeah, it's going to make that inequality true. So this ends up being an OR problem. So we know that this guy over here, in order for it to work, has to be. So negative 8a minus 3, right? Whenever you multiply negative 8 times a, and then subtract 3, in order for it to work, it has to be, this whole thing has to be greater than 11, or has to be less than 11. Those are your two conditions. Plus 3, that goes away. Negative 8a is greater than 14. Divide by negative 8, divide by negative 8, then we're going to have to switch the signs. And we're going to get 14 over 8, which is 7 over 4 negative, right? And we're going to make that into 1 and 3/4 negative. On the other side, we do plus 3, we got negative 8 less than 14, and divide by negative 8, and divide by negative 8. So we got to switch the sign the other way. And that says, hang on a second, did I do something wrong? 11 plus 3. Oh, I see. Here's my mistake. One of these should be negative 11. So let me erase. No, that was okay. This one had to be, I forgot to. This one had to be negative 11, minus 11, right there. Right, so negative 8 minus 3 has to be greater than 11 or less than negative 11, and that's what I missed. So again, plus 3, we get negative 8a less or equal to negative 8. Divide both sides by negative 8, and a is going to be greater than 1. Remember, we divide by a negative number, we got to switch the sign the other way. So my inequality, my number line looks like this. A can be values of a that we can use in here. It has to be greater than 1, or you can pick values for a that are less to the left of negative 1 through 4. So any number in between here, you can't use. So let's just try a, for example. So let me erase this, make it clearer. So if you pick 0, which is here, one of the numbers you cannot pick, and plug it in here, you get 8 times 0, negative 8 times 0, which is 0. Minus 3 is negative 3. So negative 3, absolute value is 3. Is that greater than 11? No, it's not. So you can tell that this is more. Let's pick 2. Right? Because it says I can pick 2. Right? Number is greater than 1. So let me pick 2 here. Let's just, negative 8 times 2 is negative 16. Negative 16 minus 3 is negative 19. Take the absolute value of that, and you get 19, which is greater than 11. So again, it works. And again, if you have time, pick a few numbers or another number that's less than negative 1 3/4 and see if it works. You'll see that it does. Plus 10. I don't want to do that one. Let's try 19. Try 19. So 19, let's simplify that. We get 9. Have to divide r minus 2 minus 10 less than negative 73. So we're going to do plus 10 here. Plus 10. That goes away. I'm left with 9. I have to divide r minus 2 less than, what is that? 63. Negative 63. Divide by 9. Divide by 9. Let me put it over here. We have 9 goes away. So we have absolute value of r minus 2 less than negative 7. So we should be very happy with this because let's think about this. When is the absolute value of a number going to be less than negative 7? It's impossible because by definition the absolute value of a number is what? It's either 0 or a positive number, and both 0 and positive numbers will never be less than negative 7. So you can stop right here and just tell me that there is no solution. There's nothing you can take the absolute value of and have it be less than negative 7. Okay. Okay, my pen is not. Here we go. Let's see if I want to do one more here. Just 74. Hang on a second. That's an n problem. 25, again, I'll do 25 because it's pretty, I think it's, let's see, we get 3 plus 4 times the absolute value of 3x plus 7 greater or equal to negative 89. So the first thing we do, we're going to subtract 3. on both sides. That goes away. I'm left with 4 absolute value of 3x plus 7 greater or equal to, what's that, negative 92? And then divide by 4 and divide by 4. We're going to get finally 3x plus 7 greater or equal to, Alexa, what's 92 divided by 4?
92 divided by 4 is 23.
Negative 23. Now, this one's also a nice one because if you think about it, let's think about this problem so we can set up our inequality. Take the absolute value of something so that it's greater than negative 23. In this case, it's the opposite of what we did before because this will always happen. No matter what you take the absolute value of, it will always be greater than the negative number, right? So remember, the absolute value will always be 0 or a positive number, and both of these will always be greater than negative 23. So x is all real numbers. You can plug in anything for x, and it will always make that true. All right. I don't know. Do you want me to do one more? Plus, all right, let's do 21, and that'll be the last question. This should be enough for you. 21, 2 absolute value of 10b plus 7 minus 1 greater than 73. So first thing we do is plus 1 on both sides. That goes away. 2 absolute value of 10b plus 7 greater than 74. Now divide by 2, divide by 2. Finally, simplified everything. 10b plus 7 greater than, what is that, 37. All right, so let's start thinking about this. When is the absolute value of something greater than 37? Well, under 2 conditions. One is that if you take the absolute value of a number greater than 37, that's going to be true. Or you take the absolute value of something that's less than 37, it's going to be true. So this is an OR problem. So we know now that 10b plus 7 has to be greater than 37, right? Because whatever you do over here, this, whatever answer, whatever you multiply by 10 and then add 7 has to equal a number greater than 37, or 10b plus 7 has to be less than negative 37. Those are your 2 conditions. Minus 7, we get 10b greater than 30. Divide by 10, divide by 10. So b is going to be greater than 3. So one condition is that. The other one, we're going to do minus 7. Get 10b less than negative 44. Divide by 10, divide by 10. b is less than negative 4.4. So let's graph that on a number line. The values of b that I can use and plug in here, right? It's going to be anything that is greater than 3. Anything that's greater than 3 you can use for b. And anything that is, that's the decimal there, less than negative 4.4. And it's going to work. So again, you should check. So let's pick, I don't know, 5. 10 times 5 is 50, plus 7, 57. Is the absolute value of that greater than 37? It works. Let's try a number here. Right? It says that it doesn't work. Let's try 0. 10 times 0 is 0, plus 7 is 7. And the absolute value of 7 greater than 37? No, it doesn't. Let's try on the left side of negative 4.4. Let's try negative 5. 10 times negative 5, negative 50, plus 7, negative 43. Absolute value of that is greater than 37. Yes, it is. So all those works as well. All right, so that should be nice and easy.